Morning everybody, and today we will talk about some continuous and non-continuous mesh and contacts. So if we have two different bodies, and here we have two different bodies, and we have continuous mesh, and between those bodies we have a contact, for example bonded contact, we see that everything is okay. But if we have non-corresponding mesh, if we have non-continuous meshing with non-conforming nodes and so on, we will see some geometrical patterns, we will see some problem in stresses, some problems in pressures, and if our mesh are not ideally formed and is random, we would see not geometrical pattern but something like that. And in most cases, when we talk about complex geometry, not so simple as this, not two cube, but real geometry which connected in different ways, with different sections, with different faces, and so on. And both of these faces with different geometry have non-continuous, non-conforming mesh with non-corresponding nodes on both sides. That means that we will have some problem even with bonded contact on a face of contact and on a place near this contact. And in most cases, it can cause very big problem in analyzing our solution and our result. If you take a look, you will see that we have 95, 104, 105, 97, 99, 101, 91, 106. So our result jump out of the range. We need to have 100 megapascals because it's ideal solution case. But in reason of different mesh, we have plus minus 5, 6 megapascals, so 5-6% of error, of numerical error. But it can be even more trickier case. So let's take a look into this situation. We have two bodies. Both bodies are 100 millimeters. It's a cube. It's two ideal cube, 100 millimeters, 100 millimeters, 100 millimeters. Both of them have the same material. In real life, you will often have different materials, and that's additional can be problem. We create ideal situation by adding a symmetrical constraint, symmetrical region here in y direction, symmetrical here in x direction, and symmetrical here in the direction. We have contact region fully program controlled, it's bonded, and everything is automatic. So we have only one contact pair with one contact and one target face. We have meshing. It's automatic mesh, and it creates 10 elements by age. So we have 1,000 of elements here, 10, 10, 10, 10 times 3, and 1,000 elements here. And we can see it here. So we have 1,000 here, 1,000 here, 2,000 in sum. We can see that we have quadratic elements with mid-size nodes, and we can check it. So this is our mid-size nodes, and we have mid-size on both bodies. So we have ideally conformed mesh for our situation. We have a pressure 100 megapascals, and we apply 100 megapascals to simplify calculation of percentage of error, of numerical error from mesh. We does not need here any fixation because we have symmetry which work as fixation, and in reasons that we have 3 regions of symmetry in different directions, in orthogonal directions, we have ideally constrained body which will not fly away. So we calculate and we see result, and it's very smooth, it's very cool. It can look strange in reasons that it's not deformed in any way, but as you remember, we have fixed this corner in reason of symmetry. So under the deformation, it try to change their sides. Let's do bigger scale. So it's try to increase in all directions. That's why we see those type of deformation like here. So everything okay, everything is okay. And we have stress, and this stress are 100 megapascals, not more, not less, only one digit. So everything is good. Also we have the same stress distribution on top and on the bottom of our case. Let's delete it and let's add it later. If you don't know how to do it, you will see. And also we have a contact pressure, and we can see that we have contact pressure only from one side. That's why in reason we have one contact pair with one contact face and one target face, and we see result on target face. So we also delete them. And now let's do some changes and try to see result. So first of all, I check our mesh. I choose the mesh tab on ribbon. I choose size. Change type of sizing to body. Select my body. Click apply here on the geometry. And say that I need an element size about 20 millimeters. Let's create this mesh. It's look like this one. We have one element here and two corresponding elements here. So let's solve and we see the same picture and it's also smooth. We see the same picture, the same 100 megapascals, and so we can think that it's okay. And what does this guy talk about? Some difference, about some errors. Everything is okay. Okay, let's show the stress distribution for those two faces. It will be okay, but let's show. So what do we need to do this? We need to choose solution in outline tree. We need to switch our selection to face. And for example, we can do it in several ways, and we repeat it with a several way. For the first very dumb way, I will hide this body and select this face and click stress, equivalent stress. Here we have stress distribution for this face only. Now I click stress distribution, equivalent stress, and it try to get for all bodies, and we need not to push solve or not push retrieve or evaluate result. We need to change it. We need to click all bodies and select new geometry where we want to show our result. But we don't see our face because it's on hidden object. So by left mouse button we can show all bodies and then hide the top one, but also we can invert visibility. It's a very cool feature. And select this one and click apply. So we have two different geometry. Show all bodies. One here and second here. Both inside between these bodies. Let's solve or evaluate result and we will see result which are the same. And if one of our body will be hide, we will see the one result for body which are present, and we will see no result for the second one. That's very important. You doesn't have error, you only need to show all bodies, or not all, your body. Okay. You need to add contact tool, solution, toolbox, contact tool. For all contacts, if there are some situation with complex geometry, you can change here preferences, and you can create several contact tools for different contact pairs and for different places. But for now it's okay, and we need to add contact pressure and solve, and everything is okay. So let's do one additional movement. one additional step. Let's add sizing, but not to this one, to the bottom, but let's add sizing to the top one. And let's do this size 30 millimeters. So now we have the body like this one, and we have 4 elements on the top and 5 elements on the bottom. And now we doesn't have corresponding points with meshes. And let's calculate. Let's see what we get. Total deformation looks almost the same, but we can here see some waves. Okay, let's take a look to stress distribution, and we see some very strange points. Let's take a look to stress, and it looks like this one, like flower. And let's take a look to this one, and it's look different. This one and this one, it's look different. Repeat and you will see. Let's check our pressure, and our pressure look like this one. It's not a flower, it's geometric cross. But here we doesn't see a picture, in reason that we have asymmetric contact pair with one contact and one target face. So, in reason that we have very different pictures, I want to see contact pressure on both faces, on both bodies. So I took contact region, came to details, and in behavior, here, in behavior, I open variance and choose from program controlled, which for our variant auto asymmetric, we need to change into symmetric variant. Let's select symmetric and let's recalculate. So now we have 2 pair of contact. Contact, target, target, contact. So this result the same. This result have some difference, but very close. These are different. As you see, we does not change mesh, but we obtain different variance of stress distribution and different variance of pressure distribution. And on previous version, if you stop video and return, you will see that we have the digits and the range from 90 to 106, 108. From 98 to 102, 105, something like that. But now we have range from 23 megapascals to 168 megapascals, 80 to 70 megapascals difference when we need to have one 100. So it's 80% of error. And it's not symmetrical error. It's not range. It's plus 80 minus 80%. So here you can see difference with the mesh and with the different preferences of calculation. So even bonded contact can cause our calculation and give a very abnormal result for non-continuous, for non-conforming mesh. Let's do some dumb things. Let's take our mesh and add a method of meshing for both of these parts. And our mesh will be tetrahedron. Generate. And we obtain something like that. Chaotic mesh with very different mesh with non-conformals, non-continuous meshing. Let's calculate total deformation. Look almost the same, and here we have waves, here it doesn't have waves. Okay, we have something like that on a stress distribution. It's, as you see, very different, and it's very huge range of elements. As you see, it's around 5% only, but it's difference on very simple and ideal task. If we take a look, we will see this picture and we will see this picture. Very different, with different place of maximum and minimum, with very different stress distribution. And if we don't understand that's only came from our mesh, from our chaotic mesh, from our chaotic non-continuous, non-conforming mesh, we can try to analyze those results if it will look physically with your type of boundary condition and so on, with your behavior of construction. And sometimes you will do a lot of analysis and a lot of conclusion, but all this conclusion get it from the random reason. Okay, let's take a look under the pressure, and we see very different behavior on both sides, on both cubes, and we see from 22 to 200 and almost 20, more than 100% of error. And this mesh are not so bad. Not so bad. It's not good, but it's not so bad in general. And it look like very close nodes. And we remember that we have here additional mid-side nodes, and it also very close. But we have so big difference, even in bonded contact. Okay, can we do something? Can we change those results? In most cases, in real problem, we need to split our geometry to have the same faces, and then we will have possibility to create continuous meshing. For our situation, we can create with contact mesh this why this object are present here. So here is our contact mesh tool on meshing toolbar, context meshing toolbar. So let's check this contact mesh. It creates this contact mesh group and contact mesh preferences. And we need to select both these faces to say that we need a same mesh on the both sides. And we can do it with two different ways. Let's select faces and let's click here. And we select not face we want, but also we see those group of rectangles. These rectangles have different colors and they have range. And the first one show this face, but the second show the face we need, and the color of this face show the color of body which have this face. So this face is the face of this gray object, of top object, and this face is the same face in the same place, but for bottom object. And this is this face. So, but we have additional possibilities to select those objects. It's more comfortable in very often way. Let's select display on our selection toolbar. And here we have explode mode. And if we use the slider, our assembly explode. And we will have possibility to look inside of contact, and we can select those geometry and click OK. And now reset and everything return. So now we click generate and we create continuous conforming mesh. We have two nodes in one point, one for top body and one for second, but we have continuous mesh, and we will see that this is continuous mesh later. Now let's calculate and we see the smooth result of the formation, the same stress distribution, and we can see that we have same mesh, and additionally it's very good, can be seen here. So that's why we need to have a continuous and conforming mesh in contact, even if our contact is bonded. It's very, very important. Please write your comments and question if you have below the video.